Hello friends, so in this video we are going to discuss about dimensional analysis. This is a topic of the chapter units and measurement, and this is especially for those students who are going to appear NEET and JEE exam. And here we are going to discuss the basics concepts as well as previous year's questions of NEET and JEE. Okay, so before we start, please subscribe the channel if you are new to my channel. Also share with your friends and hit the thumbs up button if you like my videos, and hit the bell icon so that you get notified when new video will be uploaded. Okay, so now let's start. So dimensional analysis. Now you see, so you can write the dimensional formula of any quantity if you know the dimensional formula of the 7 fundamental quantities. And you must know the relations of that physical quantity that you want to write, of which you want to write the dimensional formula with other known physical quantities, right? So that means, suppose first let me write the 7 fundamental quantities and their dimensional formulas. Okay, what are the 7 fundamental quantities? Fundamental quantities. So what are the 7 fundamental quantities? So those are length, mass, time, temperature, electric current, then intensity of light or luminous intensity, and amount of substance. So their SI units. SI unit of length is meter, so symbol is m, and SI unit of mass is kilogram, its symbol is kg, right? And that of time is second, so symbol is simply s, and temperature is Kelvin, measured in Kelvin, that is K, and electric current ampere, so symbol is A, right? And the luminous intensity candela, that is CD, and the amount of substance, that is mole, in short MOL we used to write. Then what are the dimensional formula for length? We simply write L. Actually what happens, so we used to write the dimensional formula in standard form, m to the power a, l to the power b, and t to the power c in MLT, with the help of MLT. So this dimensional formula of L can be written in that way: m to the power 0, L t to the power 0. Okay, you can write that way. So similarly, dimensional formula of mass, that is simply you can write m, and in this form with the help of MLT you can write m, L to the power 0, t to the power 0. Okay, so for time, so that is t, and we used to write the dimensional formula within square bracket, and it can be written as m to the power 0, L to the power 0, t to the power 1, that means simply t. Similarly, temperature, so in both cases, for time and temperature, first letter is T, that's why here we're going to use instead of T we're going to use capital K, right? Here we're going to use capital K. Okay, and for electric current we can use capital A, either capital A or you can use capital I, right? And luminous intensity you can write CD, the symbol for unit, and the symbol for the dimensional formula, that's same, and amount of substance, that is MOL, mole, right? These are the dimensional formula that you must know. And now you see, if you want to find the dimensional formula of any physical quantity, then you must know the relations of that quantity with other quantities. Suppose we need to find the dimensional formula of momentum, then momentum, we must know that momentum is equal to mass into velocity. We must know this relation, then only we can find it, right? Or you can find it from SI unit as well. So now for mass we used to write m, and for velocity, in order to find the dimensional formula of velocity, you can use here you see displacement by time. Displacement is nothing but it is a length, so its symbol will be L, and time, that is capital T, or you can simply write this one as L t to the power minus 1, right? And simply you can find the dimensional formula of this velocity from the SI unit also, because SI unit of velocity is meter per second. So meter is the unit of length, and S is the second, is the unit of time. So second inverse is there, so here T inverse. So that's how we can obtain the dimensional formula. So here you can see that we got the dimensional formula of mass and velocity, L t to the power minus 1. So combining these two, we can write the dimensional formula of momentum is m L t to the power minus 1, right? That's how we can write. So hope you have understood this, how to write dimensional formula of any physical quantity. Just suppose you need to find a dimensional formula of acceleration. So that is change in velocity by time. So change in velocity, so the dimensional formula of change in velocity will be simply that of velocity, that is L t to the power minus 1, and we have time here, so it's going to be L t to the power minus 2. So it can be written as m to the power 0 L t to the power minus 2. That's how we can find, right? You can solve the problems that those are asked in NEET and JEE if you know all the physical quantities and their all the relationships related to the physical quantities that you have got to learn in class 11 and 12, right? Then only you can solve the problems which are asked generally asked in JEE and NEET, right? Because you have studied this chapter, units and measurement, in class 11, right? But sometimes what happens, some physical quantities you haven't got all the physical quantities in the same year, in the same season, that in class 11, in the same class. Okay, some physical quantities will be introduced in class 12. So as you are going to appear the NEET and JEE after class 12, that's why you must know all the physical quantities, how they are related to other quantities. Okay, then only you will be able to solve those kind of problems. Okay, so now let's start solving previous year's questions, right? So here you see this first question is the plane angle and solid angle have, this was asked in NEET 2020. Remember one more thing, that plane angle and solid angle, this is plane angle, suppose a plane angle and solid angle, these two are dimensionless quantities. Okay, so if you have studied the first this chapter, units and measurement, then you must have got that plane angle and plane angle and solid angles. Okay, the radian, those are radian, and steradian. Okay, steradian. So these two are the SI units of supplementary quantities. Okay, and these are dimensionless. Why dimensionless? So here you see, let me explain why dimensionless. Suppose this is an arc and the arc of a circle of radius r, which makes angle theta at the center of the circle, and this is the length of the arc. Then L is equal to theta into r. Okay, L is equal to theta into r, where theta is in radian, right? So now theta will be equal to L by r. L is length. Okay, so length, its dimensional formula will be L, and radius is nothing but it is also a length. So L by L, this to gone, so it becomes dimensionless, right? So hope you have understood. Suppose this is a surface, or you can consider this is a part of a sphere. This is a surface, part of the surface of a sphere that makes a solid angle. So angle subtended by a surface, right? Not arc or not line. This is subtended by a surface at the center. Here is the radius r, and this surface area is suppose a. Then this solid angle, okay, this solid angle omega is given by area by r square. Area, what is the unit of area? Suppose this is a rectangle, this is length, this is breadth, and then L into B, it's in meter, and this is also in meter, then it will be in meter square, right? So length and breadth, these are both nothing but length, right? So meter square means meter is the unit of length L, and as we have meter square, so its dimensional formula will be L square, right? And radius is also one kind of length, so radius square, its dimensional formula will be also length square, so L square gone, so it becomes dimensionless. So both friends. So in this video we are going to discuss about dimensional analysis. This is a topic of the chapter units and measurement, and this is especially for those students who are going to appear NEET and JEE exam. And here we are going to discuss the basics concepts as well as previous year's questions of NEET and JEE. Okay, so before we start, please subscribe the channel if you are new to my channel. Also share with your friends, and hit the thumbs up button if you like my videos, and hit the bell icon so that you get notified when new video will be uploaded. Okay, so now let's start. So dimensional analysis. Now you see, so you can write the dimensional formula of any quantity if you know the dimensional formula of the 7 fundamental quantities. And you must know the relations of that physical quantity that you want to write, of which you want to write the dimensional formula, with other known physical quantities, right? So that means, suppose first let me write the 7 fundamental quantities and their dimensional formulas. Okay, what are the 7 fundamental quantities? Fundamental quantities. So what are the 7 fundamental quantities? So those are length, mass, time, temperature, electric current, then intensity of light or luminous intensity, and amount of substance. So their SI unit of length is meter, so symbol is m, and SI unit of mass is kilogram, its symbol is kg, right? And that of time is second, so symbol is simply S, and temperature is Kelvin, measured in Kelvin, that is K, and electric current ampere, so symbol is A, right? And the luminous intensity candela, that is CD, and the amount of substance, that is mole, in short MOL we used to write. Then what are the dimensional formula of for length? We simply write L. Actually what happens, so we used to write the dimensional formula in standard form, m to the power a, l to the power b, and t to the power c in MLT, with the help of MLT. So this dimensional formula of L can be written in that way: m to the power 0, m to the power 0, L t to the power 0. Okay, you can write that way. So similarly, dimensional formula of mass, that is simply you can write m, and in this form with the help of MLT you can write m, L to the power 0, t to the power 0. Okay, so for time, so that is t, and we used to write the dimensional formula within square bracket, and it can be written as m to the power 0, L to the power 0, t to the power 1, that means simply t. Similarly, temperature, so in both cases, time and temperature, first letter is T, that's why here we're going to use instead of T we're going to use capital K, right? Here we're going to use capital K. Okay, and for electric current we're going to use capital A, either capital A or you can use capital I, right? And luminous intensity you can write CD, the symbol for unit, and the symbol for the dimensional formula, that's same, and amount of substance, that is MOL, mole, right? These are the dimensional formula that you must know. And now you see, if you want to find the dimensional formula of any physical quantity, then you must know the relations of that quantity with other quantities. Suppose we need to find the dimensional formula of momentum, then momentum, we must know that momentum is equal to mass into velocity. We must know this relation, then only we can find it, right? Or you can find it from SI unit as well. So now for mass we used to write m, and for velocity, in order to find the dimensional formula of velocity, you can use here you see displacement by time. Displacement is nothing but it is a length, so its symbol will be L, and time, that is capital T, or you can simply write this one as L t to the power minus 1, right? And simply you can find the dimensional formula of this velocity from the SI unit also, because SI unit of velocity is meter per second. So meter is the unit of length, and S is the second is the unit of time, so second inverse is there, so here T inverse. So that's how we can obtain the dimensional formula. So here you can see that we got the dimensional formula of mass and velocity, L t to the power minus 1. So combining these two, we can write the dimensional formula of momentum is m, L t to the power minus 1, right? That's how we can write. So hope you have understood this, how to write dimensional formula of any physical quantity. Just suppose you need to find a dimensional formula of acceleration. So that is change in velocity by time. So change in velocity, so the dimensional formula of change in velocity will be simply that of velocity, that is L t to the power minus 1, and we have time here, so it's gonna be L t to the power minus 2. So it can be written as m to the power 0 L t to the power minus 2. That's how we can find, right? In case of plane angle and solid angle, therefore they have units. To measure the plane angle we have units radian, and to measure the solid angle we have steradian. They have units but no dimensions. Okay, so they have units but no dimensions, so option D is correct. So hope you have understood this. Now let's move on to next question. So here is the next question. So we need to match those left hand side and right hand side column. So gravitational constant, what will be the, these are some physical quantities given on left side, and their corresponding dimensional formula on the right hand side, we have to match them. So now you see gravitational constant, universal gravitational constant G. So we know F is equal to capital G m1 into m2, both represents mass, by r square, right? So capital G is equal to F into r square, it is nothing but distance, you can say, that will be length, right, by m1 into m2. So force, we know that force is mass into acceleration, mass into acceleration, mass into acceleration, that is force. For mass we will get capital M, acceleration L t to the power minus 2, then there is r square. For r square it is also one kind of length, so we will get L square. Then m1 into m2, that is mass into mass, that is m square, right? So what will be the dimensional formula? If you simplify this, then m to the power minus 1, then L to the power 3, t to the power minus 2. So this is going to be the dimensional formula of G, capital G. So check which formula, which option is correct here. So here you see this match with this. This is the dimensional formula of capital G. So next one we have gravitational potential energy. Okay, so when we say energy, energy is equivalent to work done. Energy is equivalent to work done. So what is the dimensional formula of work done? Work done is force into displacement, right? Force into displacement, and force is mass into acceleration, mass into acceleration, and into displacement, right? So here you see, let's do it, mass into acceleration into displacement, right? So displacement, so for mass we will get m, acceleration, for acceleration L t to the power minus 2, and dimensional formula of displacement, that's going to be length, so m L square t to the power minus 2. So this is the dimensional formula of energy. So we have got A match with 2, then B, its dimensional formula is here 4, B 1 4. Now let us check these two quantity. So if for these two, only two options left, this one and this one. So if we check only one, that's enough, because the last one it will be clear from the picture, right? So gravitational potential, right, that's gonna be gravitational potential. Here you can see, let me clean these things first. So that will be given by gravitational potential, that will be given by energy divided by mass, right? So we have already got the dimension formula of energy, that is m L square t to the power minus 2, right, divided by m. In that case, this m cancel, so we have L square t to the power minus 2, right? So this is the option, right? So this is the dimensional formula. So here there should be minus sign. Okay, this option is L square t to the power minus 2, right? This option is let me write it properly. This option is this should be minus 2, right? L square t to the power minus 2. Okay, this is the option. So here we have got C, dimensional formula of C in 1, right? And so we have left only D, that is intensity, that must be this one, Lt to the power minus 2, right? Number 3. So from here this option A contains all these 4 result, right? So this is the correct answer. So hope you have understood this. Now let's move on to next question. Here the next question: if the force F, acceleration A, and time t are chosen as the fundamental physical quantities, then we need to find the dimension of energy, right? So that means in this case here force, acceleration and time, these quantities are taken as fundamental quantities. Okay, so we have to express the dimension of energy. We know that dimensional formula of energy is m L square t to the power minus 2, right? But we have to express this dimensional formula in terms of F, A and T instead of M, L, T, right? So how to do that? So for that case, let us consider that the energy, its dimensional formula is equal to, so F to the power A to the power B and T to the power C. Let us consider that way, right? Then dimensional formula of energy, I have already shown earlier how to find the dimensional formula of energy, that is m L square t to the power minus 2. And here let's put the dimensional formula of force. So dimensional formula of force is m L t to the power minus 2, and as there is power A, so that's why it will be m to the power A, L to the power A, t to the power minus twice A. Then dimensional formula of acceleration is L t to the power minus 2, right? As we have B here, power B, so we can write L to the power B, t to the power minus twice B. And dimensional formula of time is simply t, which is t to the C here. So we can write this as m to the power A, L to the power A plus B, right? L to the power A, L to the power B, so L to the power A plus B. Then t to the power minus twice A minus twice B plus C, right? Now m L square t to the power minus 2. So let us compare the powers of m. Here power is 1, so we will get that A is equal to 1, right? Then power on L is A plus B, and on the left hand side we have 2, so A plus B is equal to 2. That's why if you put the value of A here, then you will get B is equal to 2 minus A is 1, so that's why B is also 1. Then how to find C? Here you see this is minus 2, right? Minus twice A minus twice B plus C, that's going to be minus 2. And let us put the value of A, which is 1, so minus 2. B is also 1, so minus 2 into 1 minus 2 plus C is equal to minus 2. This minus 2, this minus 2 cancel, so C is going to be equal to plus 2, right? So our dimensional formula will be, if you put the value of A, B, C here, then dimensional formula of energy will be energy in terms of F, A and T. That F to the power A, value of A we have got 1, A to the power B, B is also 1, F to T to the power C, C is 2. So this is going to be the dimensional formula of energy in terms of F, A and T, right? So hope you have understood this. So which option is correct? So this is option C, right? So hope you have. So here it is given that a physical quantity of dimensions of length. That means there is a physical quantity, so let that quantity be q, and its dimensional formula is that of length, and can be formed out of these three c, capital G, and e square by 4 epsilon naught, right? So using these three, here c is the velocity of light, g is the universal constant of gravitation, and e is the charge of electron here. So we combining these three, we have got those expressions here in the option. So which option gives you the length of the give you the dimension of length? So let me find that one. So here you see, first let us find the dimension of c. So c is the velocity of light, so velocity, so that's why its dimensional formula should be L t to the power minus 1, right, because it is velocity. And g we know this universal gravitational constant, that's going to be equal to F, then dimensional formula of r square by mass into mass, right? So force is mass into acceleration, so m L t to the power minus 2, so then r square, that's going to be L square, right, by m into m means m square, right? So here we're gonna get m to the power minus 1, L to the power 3, t to the power minus 2. So this is the dimensional formula of z, right? So this is the dimensional formula of z. Now e square by 4 pi epsilon naught. So we know that dimensional formula can be found out from the SI units, and SI unit charge is coulomb, so there should be coulomb square for E square, and 4 pi epsilon naught, right? 4 pi epsilon naught, and its SI unit is c square n to the power minus 1 minus 2 square, m to the power minus 2 actually, okay, m to the power minus 2. You're gonna get this things in class 12. If you are in class 11, so I don't think you are aware of this. So here you will get this in class 12, right? So now you see, so here's column gone, so this is n to the power minus 1, that can be written as n, here m to the power minus 2, so m square. So Newton is 1 kg per meter square, Newton 1 Newton is equal to 1 kg into 1 meter per second square, right? So here kg meter per second square, then again we have here meter square, so it's gonna be kg meter cube second square. So kg is the unit of mass, so this is the mass, and meter is meter cube, that's gonna be the length, unit of length, so L cube, and second is time, unit of time, so second to the power minus 2, that should be t to the power minus 2. So that is why dimensional formula of this term, that E square 4 pi epsilon naught, its dimensional formula must be m L cube t to the power minus 2, right? So hope you have understood this. So now we have got the dimensional formula of z, c, and this quantity E square 4 pi epsilon naught. So let me clean this thing. So this is the dimensional formula of gravitation, right? Okay, universal gravitational constant, let me write this one here, okay, and this is this quantity, right? So let us write this thing. Now here you see a physical quantity of dimension of length that can be formed out of these three, right? So from out of these three, so that means we are going to have a physical quantity. Let me divide it. Physical quantity, let that quantity be q, which is dimensions of length, okay, dimension of length, and which is make out of this three dimension of C, dimension of G, and dimension of E square by 4 pi epsilon naught, right? So let us consider that Q quantity, that required quantity B, is equal to C to the power here. This is suppose is X, and this is suppose Y, and this is suppose Z. Okay, because we don't know that how this Q is related to this these three quantities, right? So that's why we have taken X, Y, Z. Okay, so as in the question, this quantity has the dimension of length, so we can write m to the power 0 L t to the power 0, right? And what is the dimension of C we have got? That is L t to the power minus 1. So power on it is suppose X, so that's why we can write L to the power X t to the power minus X, right? So then G is, we have m to the power minus 1 L cube t to the power minus 2, and as here we have taken Y, so that's why we can write m to the power minus Y L to the power 3Y Z to the power t to the power minus twice Y, right? And let me write this one here, just wait. Okay, bit of adjustment here. So here let me write it properly. L to the power 3y. So that's what we will get. Then this one, m to the power 1 L to the power 3 and t to the power minus 2, right? T to the power minus 2, as power on this is Z, so that's why we can write here, we can write that m to the power x, sorry not x, Z, and 3 to the L to the power 3Z t to the power minus twice Z. That's what we can write. So let me write these things clearly. Okay, just wait. So this is the dimension of just wait. So because of this power x, this can be written as x to the power L to the power x t to the power minus x, right? Then we have z here. This is the dimensional formula of z, and this is z to the power y, so we can write m to the power minus y L to the power 3y and t to the power minus 2y. So on this quantity we have power z, so we can write m to the power z L to the power 3z and t to the power minus 2z, right? So now simplify, we will get m to the power minus y, and here also we have m to the power z, so plus z, then L to the power, here we have x, then we have 3y and 3z, so m to L to the power x plus 3y plus 3z, then t to the power, so minus x minus twice z, right? Sorry, twice y, then we have minus twice z. So this is the result we should get. So t to the power minus x minus twice y minus twice z, that's what we have got, right? So hope you have understood this. Now compare the powers. So m to the power L to the power 1 and t to the power is 0. Now so here m to the power 0, power on m here y minus y plus z is equal to 0, that's why here it implies y is equal to z or z is equal to y. Similarly, so here you can see that x plus 3y plus 3z on the left hand side, L to the power 1, so we will get x plus 3y plus 3z, that's going to be equal to 1, and this one you can see here power on t is 0, so minus x minus twice y minus twice z, that's going to be equal to 0. Okay, so adding these two equations, what we will get, so here minus x plus x is going to be cancelled, we will get y, and here you see 3 minus z, that's going to be plus z, is equal to 1. That's what we will get, right? So as z is equal to y, if you put z is equal to y, right? So if you put z is equal to y, right, so then we will get y plus y is equal to 1. That's going to be twice y is equal to 1. So what we have done, we have used this equation here, right? So this z is replaced by y because z is equal to y. So this is going to give you y is equal to 1 by 2. So we have got the value of y. Since z is equal to y, so this will be the value of z as well. So that y is equal to z is equal to both equal to half, right? So then let's put the value of y and z here in this equation, any one of this one or this one, to get the value of x. So let me take this one. This equation is let me write here this equation. This equation is minus x minus twice y, then minus twice z is equal to 0. So y is equal to, we have got half, z is also equal to, we have got half. So here 2 cancels, 2 cancels. So we have got minus x minus 1 is equal to 0. That means minus x minus 2 is equal to 0, which means x is equal to minus 2, right? So or minus x is equal to plus 2, that means x is equal to minus 2. So we have got x is equal to 2, y is equal to, and z is equal to half, right? So let me clean this part. Okay. So what we have got x is equal to minus 2, y is equal to, z is equal to, both equal to half. That's what we have got, right? Now what we're going to do, we're going to put these values of x, y, z here in this first equation. Okay, so let me clean our things here. Okay, let me clean all these things. Okay. So if you put the values of x, y and z, then what you will get, that c to the power, right, c to the power minus 2 and g to the power half and e square by 4 pi epsilon naught, that's going to be equal to half. So which is nothing but c square, sorry, not c square, 1 by c square, that's going to be 1 by c square, z to the power half. So we can write z into e square by 4 pi epsilon naught whole to the power half. So which option is correct here? So I think option D option is correct. So hope you have understood this. So now let's move on to the next question. So here you see, which of the following combinations has the dimension of electrical resistance? So here epsilon naught is permittivity of vacuum, and this mu naught is the permeability of vacuum. So first let me find the dimensional formula of resistance. We know resistance is equal to V by I, and V is equal to W by Q, work done per unit charge, right? Then again Q is equal to I into T, right? Because I is equal to Q by T, that's why Q must be equal to I into T by I. So that's gonna give you W I square into T, right? That's what we're gonna get. So dimensional formula of resistance, that's gonna be dimensional formula of work done by dimensional formula of current square and dimensional formula of time t. So here work done, that is nothing but force into displacement. Force we know m l t to the power minus 2, mass into acceleration, right? Then into displacement, again there will be L, so we can write L square t to the power minus 2, right? M L square t to the power minus 2, that's the work done. So here I, for current we used to write A, so A square, then t to the power 1. So if you simplify this, you will get M L to the power T to the power minus 3, A to the power minus 2, right? That is the dimensional formula of resistance. So hope you have understood this. Now let me clean these things, right? Just let me write this one here. So this is the dimensional formula of resistance. So hope you have understood how we have got this. So now here you see, remember that mu naught so this permeability of vacuum, that is given by this 2 pi. This is the formula, 2 pi into force into distance 2 pi into, just wait, 2 pi into force into distance divided by current into length, right? So let me write this one clearly. So this is the formula to calculate permeability of free space, right? Twice pi, that is dimensionless constant, so we're gonna ignore this. So dimensional formula of mu naught, that's why it's gonna be equal to force and distance, that's gonna be nothing but length, right, by current. So here we have current into current, so we can write A square, then length L. So here this length will be cancelled out each other, right? So and dimensional formula of force, mass into acceleration, mLt to the power minus 2 by A square, right? So we can write that dimensional formula of mu naught, that permeability of free space, that's going to be equal to mLt to the power minus 2 A to the power minus 2. This is the dimensional formula of permeability of free space, right? So this is the dimensional formula of permeability of free space. Okay, so hope you have understood this. So now let's find the permittivity of vacuum or free space, right? So that formula is epsilon naught, that's going to be equal to charge into charge, that means charge square divided by 4 pi into electric field. So here it should be electric force actually, 4 pi epsilon, this is 4 pi electric force, this is electric force, not field. So electric force. So here you see, so therefore dimensional formula of epsilon naught, so charge is square, charge is current into time t, so square. But here we're gonna ignore this because this is dimensional constant. As you and when we say force is always mass into acceleration, then distance square, that's gonna be L square, right? So here dimension of current, here we're gonna write A, so as there is a square and that of t is time here, so m L cube t to the power minus 2 if you multiply these two, right? So simplifying this, what are we gonna get? Just let me cut these things. If you simplify these two, so what you will get, m to the power minus 1, L to the power minus 3, then t to the power minus 4, that's going to be plus 4, then A square, that's what we're gonna get. This is the dimensional formula of permittivity of free space. So here we have got permittivity of free space, epsilon naught, dimensional formula of permittivity of free space. So let me clean these things. So here you see, it will be easier to find the answer if we first find the ratio mu naught by epsilon naught or epsilon naught by mu naught. Let me find first this one. Okay, so if you find that mu naught by epsilon naught, its dimensional formula, ratio of their dimensional formulas. So this is the dimensional formula of mu naught. So first let me write this one. This is the dimensional formula of mu naught, then by that of epsilon naught, right? So that of epsilon naught, this is the dimensional formula of epsilon naught. If you find this ratio, then what you will get? You will get m square, right? M square, just wait, then t to the power minus 4. This is t to the power 1, this is minus 3, so 1 plus 3, that's going to be plus 4. T to the power plus 4, sorry, not t to the power, L to the power plus 4, then t to the power minus 2 minus 4, that's going to be minus 6, and a to the power minus 2, then this 2 here, minus 2 minus 4, right? So this is what we have got. Now you can see clearly, if you write this on this way, that m l square t to the power minus 3 a to the power minus 2 whole square, right? Then you can see clearly this is the dimensional formula of resistance, right? So we can say from this result mu naught by epsilon naught is equal to resistance square r. So if r square is mu naught by epsilon naught, then r must be equal to root over epsilon naught by, sorry, mu naught by epsilon naught. So this is the result. So here the correct option is A. So hope you have understood this. Now let's move on to next question. So next question, you see in the formula x is equal to 5yz square, where x, z have the dimensions of capacitance and magnetic field respectively. What are the dimensions of y in SI units? So here you see the given expression is x 5 y z square. Here this x as the dimension of capacitance, and we know that q is equal to c into v. So here v is the potential difference and c is the capacitance. So capacitance, you're gonna get it in class 12. Capacitance c is equal to q by v, right? And here you see dimensions of c, that means capacitance, that gonna be equal to dimension of q. Q is I into t, right? Current into time. E and potential is w by q. Again q is I into t, right? So that's why we're gonna get I t whole square by work done w, right? Work done w. So here this for current I, we're gonna use A, and for time capital T there will be square. Work done is force into displacement, so this is force is mass into acceleration m, L t to the power minus 2, and again into displacement, that is nothing but L, so here we have to write L square, right? So in that case, so what will be the capacitance, dimensional formula of capacitance, m to the power minus 1 L to the power minus 2, right? Then t to the power plus 4 t to the power plus 4, then a to the power minus 2, sorry, plus 2, a to the power plus 2, right? So that should be the dimensional formula of x. So now you see, let me clean these things. Okay, let me clean these things. Here you see, so this is what, this is the dimensional formula of capacitance we have got, right? So now just do it and let me. Now here you see it is already given that Z has the dimensional formula of magnetic field. Dimensional formula of magnetic field, which is B, and we know that B is equal to F by q into v we have already discussed. Here v is not the potential, here v is velocity. Okay, here v is velocity, so don't be confused here. So magnetic field, here we're gonna get force and charge q into v, velocity, right? Force, mass into acceleration, right? Then q, that current, into time, so that's going to be a t, right? And velocity l t to the power minus 1, l t to the power minus 1. So if you simplify all these things, then you should get z is equal to, so m l to the power 0 t to the power minus 1, then sorry, not minus 1, minus 2, that remains minus 2. This is t to the power 1 and t to the power minus 1 gone, right? So then a to the power minus 1, that is the dimensional formula of z. Now from this relation here you can see this 5 is dimensionless constant, so dimension of y we can write that x by z square, dimension of x by dimension of z square. So what we can do here, let me write here, dimension of x is this, what we have got, m to the power minus 1, l to the power minus 2, t to the power 4 and a to the power 2, and dimension of z is this, m l to the power 0, t to the power minus 2 and a to the power minus 1. And if you square this, then what you gonna get, then you're gonna get m to the power 2, l to the power 0, t to the power minus 4 and a to the power minus 1. That's what we're gonna get, right, on squaring z square. So hope you have understood this. Now if you simplify this, then what you're gonna get, so if you simplify this, then you will have m to the power minus 1, minus 1, minus 2, minus 1, minus 2, minus 3, right, m to the power minus 3, then l to the power minus 2 plus 0, that is minus 2, and t to the power 4 plus 4, that's going to be 8, t to the power 8, and a to the power 2 plus 2, that's going to be 4, a to the power 4. This is the answer. So which option is correct? I think C, option C is correct. So our next question is, here you see, in a typical combustion engine, the work done by a gas molecule is given, the W is equal to alpha square beta e to the power minus beta x square by kt, right, where x is the displacement, k is the Boltzmann's constant and t is the temperature here, and alpha and beta are constant. It is not said that they are dimensionless constant, it is only said that they are constants. Okay, so we need to find the dimensions of A, right? So here you see, let me show you here. So first of all, take an important note that exponential function trigonometric function and logarithmic function are dimensionless. Okay, remember these things. Okay, so this is very important things, so note it. So exponential function, trigonometric and logarithmic functions. So here you see we have seen here an exponential part, so which must be dimensionless, right? So here you can see work done W, here the dimension, here it is, the formula is, the relation is given that W is equal to alpha is equal beta, not b, beta e to the power minus beta x square by kt, right? So this is the formula given, or given relation. So here dimensions of work done must be equal to dimensions of alpha square into beta square, because this part is dimensionless. Okay, so e to the power minus beta x square by k t is equal to dimensionless means m to the power 0, l to the power 0, t to the power 0, right? And one more thing, if this whole thing is dimensionless, then the power on e, it must be also dimensionless, right? This must be also dimensionless. So that means we can say that beta x square by kt, this is also dimensionless, m to the power 0, l to the power 0, t to the power 0, right? And from here we're going to find the dimension of beta, right? We're going to find the dimension of beta. So how to find that? Here you can see this implies that dimension of beta, that's going to be equal to kt, dimension of kt by x square, dimension of x square, right? So this is nothing but 1, right? So from this relation we have got this. Okay, so now you see, so kt, okay, remember one more thing, energy of gas molecule, that is given by, if you have studied thermal physics, then you must have got this. E is equal to 7 by 2 kt, right? Kt. That's why this kt term, it must have the dimension of energy, right? So we can replace this kt, dimensional formula of kt, by dimensional formula of energy, right? Because both same, right? So now so if you had taken the notes, let me clean this part. Just pause the video and note these things. Okay, these are very important things, right? So here you see that dimensional formula of beta. We know that dimensional formula of energy, that is force into displacement. Force is mlt to the power minus 2 into again L, so here it must be L square, right? So we have to write the dimensional formula of energy is ml L to the power 2, t to the power minus 2, right? Then the dimensional formula of x, that is, in this case x is the displacement here, so it must be length L square, right? And if you simplify this, so you should get, so let me copy this one, just wait. Okay, so just let me write here. So dimension of beta, it must be m l to the power 0, that's l square gone, t to the power minus 2. That's what we have got, right? This is the dimension of beta. So from here, here you can see from this relation, that dimensional formula of from this relation, you can see dimensional formula of work done is equal to dimensional formula of alpha square beta square. So this implies that dimensional formula of alpha square, that must be dimensional formula of work done by the dimensional formula of beta, right? Dimensional formula of beta. So that's going to be the dimensional formula of alpha square. So dimensional formula of alpha square, that must be dimensional formula of work done, which is equivalent to energy. So we know the that is m l square t to the power minus 2 by a dimensional formula of beta. So dimensional formula of beta is this, we have got this one, m l to the power 0, t to the power minus 2. That is the dimensional formula of beta we have got. So now what we can do, that here you can see, if you simplify this, let me divide this. Okay. If you simplify this, so dimensional formula of alpha, this is alpha square, so you must get the dimensional formula. If you simplify this part, then what you will get, gonna be cancelled, so m to the power 0, l to the power 2, t to the power 0 again, t to the power 0, and whole to the power half, because we had here alpha square, so that of alpha, dimensional formula of alpha, so it should be half, power should be half here. So in that case, what we will get, m to the power 0, l to the power 1, l, because l is square to the power half, that's going to be l, right? So hope you have understood this. These are very basic things. I don't think you need I need to explain these things. So this is the dimensional formula of alpha. So which option is correct? Which option is correct? Here you can see option B is correct. M to the power 0, L, T to the power 0. This option is correct. So hope you have understood this. Now let's move on to the next question. So now here is the next question, an expression for dimensionless quantity. Here P is the dimensionless quantity, and this is given by this relation, and alpha and beta are constants. So it is not mentioned that alpha and beta are dimensionless constant. These are only constant, not dimensionless. Okay, they may have dimensions. So x is distance, k is Boltzmann's constant, t is temperature. We need to find the dimension of alpha. That means alpha must have dimension here. So here you see, first let me write the given function, given relation, that is p is equal to alpha by beta log k into t by beta x. As you see, I have already mentioned in the last problem that we have solved that logarithmic function, trigonometric function, exponential function, these are dimensionless. Now if this is dimensionless, then this part must be also dimensionless, right? Okay, so then this kt by b of x, beta x, this must be also dimensionless, m to the power 0, l to the power 0, t to the power 0. And if you simplify this, then dimension of beta, that's going to be equal to dimension of k into t by dimension of x, then m to the power 0, l to the power 0, t to the power 0, and this part is not necessary here, so you can ignore it. M to the power 0, L to the power 0, T to the power 0. So now here you see, so dimension of beta, dimensional formula of beta, here kt is nothing but, again it must be energy, right? Kt is energy, I have already told you, that is energy, and x is the dimension of length, right? This is distance, x is distance, so we're going to use the dimension of length, that is L. So here you see dimensional formula of beta. So dimensional formula of energy is given by m L square t to the power minus 2 and divided by again L. So it's gonna give you m L to the power 1, that is simply L, t to the power minus 2. So this is the dimension of beta, dimensional formula of beta, right? Now we are to find the dimensional formula of alpha. So from this relation, if this part is dimensionless, then from this part p is equal to alpha by beta. So we can write that dimensional formula of p is equal to dimensional formula of alpha by dimensional formula of beta. And one more important thing is given, that p is dimensionless quantity p, right? If p is dimensionless quantity, so its dimension must be m to the power 0, l to the power 0, t to the power 0, and dimension of alpha that we need to find, and dimension of beta we have already got, mlt to the power minus 2, mlt to the power minus 2, right? So this implies, so let me separate it. This implies that dimension of alpha is equal to m to the power 0, l to the power 0, t to the power 0 into m l t to the power minus 2, right? m l t to the power minus 2, which is going to give you dimensional formula of alpha, that is equal to m l t to the power minus 2, because here you see we have power 0 on all the three, so we will get the dimension of beta here, right? So this is the dimensional formula of alpha, right? So hope you have understood. So this is, here you can see this is m to the power 0, l to the power 0, t to the power 0. So here m to the power 1, so m to the power n, m to the power 0 plus 1, that's going to be simply m, right? Hope you have understood this calculation and this simplification. This is very simple, right? So this is the dimension of alpha. So which option is correct? So let me check. Yeah, so it seems to be C. C is the correct option, right? So here, so hope you have understood. So how we have solved those questions, so which were asked in JEE, NEET, right? This was also asked in JEE. This was also, this was also asked in JEE 2019. So similarly, this was asked in NEET. Okay, so NEET 21. So NEET 22. So we have solved those problems. Those are asked in NEET and JEE. So here you see, I would like to say that you will able to solve those kind of problems if you know the all the physical quantities and how they are related to each other, their formulae and relationships between the quantities, physical quantities. Then only you can solve these kind of problems, which were asked in, which are generally asked in JEE and NEET entrance examination. So hope this topic is dimensional analysis. This topic is clear to you. So if you have any doubt, then please let me know in the comment box. And if you are new to my channel, please subscribe the channel, share with your friends. If you like the video, then hit the thumbs up button. Also hit the bell icon so that when new video will be uploaded, you get notified, right? So see you in the next video. Thank you for watching. Bye.